If I were to say 5 million people, you'd probably think that I was talking about the TV viewing figures for the last Six Nations match. Well, you'd be wrong. It's actually the number of people who travel using SNCF Voyageurs each day. And for that, we need to run about 15,000 trains. Yes, you heard that right. Of course, when you climb aboard a train, you don't think of that. But things don't run smoothly through pure chance. Behind every journey, there's an unimaginable level of engineering and logistics. Sometimes there are up to 5 onboard computing networks, 140 software applications, and hundreds of kilometers of electric and electronic cables for every train. A genuine rolling data center, so every passenger can travel safely and with confidence. At the SNCF, maintenance is much more than a concept. It's our reality. SNCF Voyageurs has always sought to build on solid foundations. 2,200 engineers and technicians from the rolling stock engineering division who specialize in the train's technical systems and functions. And since 2013, we've been bolstering this expertise, bringing in new skills through data scientists, data analysts, and data engineers, able to exploit the data from the trains. Cyril, what technological changes have had the biggest impact on maintenance practices?
Since 2009, the rolling stock has become extremely complex and integrated data transmitting capabilities. In 2013, we put in place predictive maintenance to increase the number of trains running, as well as the level of comfort on our lines.
Predictive maintenance sounds promising, but how does it work?
If you want to be more specific, it comes down to 3 things. First, knowing the state of each train in real time. Second one, anticipating failure. And 95% of time, we get it right. We predict the right day. By analyzing failures that have already arisen in the past, we look for early warning signs that foreshadow operational issues. And we keep a close eye on them to signal and anticipate failures. Finally, suppressing some systematic preventive maintenance. Indeed, if we are able to continually fully test the functionality of certain systems, we can eliminate the regular tests and checks and save labor hours as well as increase the operational availability of assets, rolling stocks, and workshops. We are basically automating maintenance.
Okay, sounds great on paper, but how do you actually make it all happen?
To do all of this, we quickly understood that we need to build an end-to-end predictive maintenance chain.
We've also invested equity in computer systems and IT infrastructure. We're experimenting with big data, exploiting artificial intelligence, models, algorithms, and equations. And today, all these tools help simplify maintenance. Pierre, how does AI help you in improving your CBM models?
So currently, more than 500 connected trains transmit data from various onboard systems, such as doors, brakes, or traction motors. To implement predictive maintenance on such a large fleet, we integrated system expert algorithms into the SNCF maintenance processes.
Was it easy to implement from the start?
Implementing and validating these algorithms required specific time and resources, in particular, testing and feedback gathering. As a result, deploying such a solution on a new train series used to take several years of operational data.
Do you have a concrete example from the field?
Yes. By leveraging AI, predictive maintenance services can now be rolled out within months of a train's commercial launch, instead of wasting years of maintenance feedback.
SNCF Voyageurs is constantly optimizing maintenance all throughout the lifespan of its trains, from delivery to decommissioning, from older equipment to more recent additions, but always in compliance with European standards and safety rules in force. We also support transport authorities to choose and acquire the right equipment, to undertake approval tests, to manage component obsolescence, to carry out mid-life operations, renovation, and to recycle equipment that has reached the end of its useful life. The experience of SNCF Voyageurs shows how, over time, we can optimize maintenance advised as standard by manufacturers. Through investment, feedback, engineering expertise, and accurate understanding of regulatory and safety requirements, the Matériel Engineering division knows how to improve its ways of working. Jan, what exactly is the role of the rolling stock engineering division?
This engineering division has a wide range of skills in rolling stock technology. We use this expertise during the entire life cycle of complex systems, from procurement to decommissioning, including operation upgrades.
What's the part of data in maintenance?
With our skills, experience in maintenance, and a lot of technical knowledge, we review millions of feedback data points. By combining these insights with onboard data, we create effective strategies to improve maintenance process.
And do you have another example of the use of data?
Yes, by deeply understanding data usage and comprehensive knowledge of the operating train fleet, we keep a close watch on rail infrastructure and develop use cases to minimize the carbon footprint of trains.
Have you already rolled this out widely in the field?
Currently, we manage 1,200 train fleet where we can apply the 3 optimization levels defined by Cyril.
AI, CBM, Télédiagnostics, predictive maintenance. SNCF Voyageurs uses all these tools every day in its design offices and its workshops to keep maintenance simple, drive down costs, and increase the number of trains. When new rolling stock is put in service, starting operations directly using onboard data allows for greater efficiency in building an optimized maintenance plan through CBM. And this task was made possible thanks to the rolling stock engineering teams who carried out in complete autonomy. We often say it's hard to make things simple, but the SNCF Voyageurs team has done it.